Hi, I'm Roger Barlow, Principal Product Manager with F5 Cloud Services, and I'm going to show you how you can ensure high availability and application performance with the simple, intelligent F5 DNS Load Balancer Cloud Service. In this demo, we're going to build a load balancing configuration to help ensure GDPR compliance by directing traffic from the European Union to app instances in the EU. Let's assume our demo application is at f5csdemo.com. We'll use 2 app instances to handle clients globally and another 2 instances specifically located in the EU. We'll start by navigating to the DNS Load Balancer Cloud Services tab. We've already created a service instance for our f5csdemo.com zone. You can see that we don't have any load balanced records configured yet for this service. We'll configure a rule to help with GDPR compliance in a moment, but first let's look at the elements that the rule will depend on. We've already added our app instances to the system. It's just a matter of specifying the IP and the port required to reach the application. We refer to these as IP endpoints. You can see we have 2 app instances to handle clients globally and another 2 instances specifically located in the EU to handle EU-based clients. We've also grouped the app instances into pools. Pools define how we want to balance across the instances and ensure that if an instance fails, another can transparently continue to service clients. Looking at the specifics of the EU pool, we can see the EU app instances are associated in that they're monitored for availability by a monitor we've already defined named Website Monitor. Similarly, the details of the global pool reveal that we've associated the global app instances and leverage the same monitor. A monitor simply defines the protocol, port, and specific tests to execute to verify that an app instance is alive. In clicking into the Group into Regions tab, we can see the region configurations that will define how the geo-IP balancing is to be handled. You can see the Everywhere region includes all 7 continents of the world. And the Europe region is limited to only the continent of Europe. Now let's create our load balanced DNS record that puts these elements to use. For our application, we're going to create a load balanced record for www. But since we're here, we'll also create a couple of other aliases to cover anyone who makes a typo. We'll ensure the record is enabled and configure it as an A record. And in the Proximity Rules section, we'll configure the geo-IP balancing. We'll create one proximity rule sending all clients to the global pool and give it a relatively low weight. Then we'll create a second proximity rule to send clients from Europe to the EU pool. We'll give this rule a higher weight, which will cause it to override the previous rule when it's matched. We'll save our load balanced record, then enable our service. The configuration is then pushed out to our globally distributed, Anycast-fronted infrastructure and instantaneously ready to service clients of the application. You'll know that the deployment is complete when the status shows active. Now let's switch over to the terminal to verify the configuration. Here we have a terminal on a system in the US and another in the UK. We'll issue DNS queries on each and verify the DNS responses for the respective region the system resides in. I've included a screen capture of our endpoint configuration to make the verification easier. We can see the system in the US is getting a response directing it to a global app instance. And the system in the UK is getting a response directing it to the UK app instance. F5 Cloud Services makes it easy to utilize intelligent DNS load balancing technologies. Built on a globally distributed Anycast network, clients are automatically directed to the nearest load balancer instance in the cloud. F5 Cloud Services, as fast as you are.